Device equipment manufacturers are under pressure to shorten product time to market, yet they need to ensure product safety. Product developers are also under pressure to stay ahead of the competition. Plus, manufacturers need to shorten times to market and complete product safety tests set by regulatory bodies. USB Type-C will be the most powerful and popular interface in the industry. All a consumer will need is one connector for many devices. There are challenges faced when using traditional materials. Liquid crystal polymers are widely used for micro USB connectors, yet these connectors require thinner walls than previous generations. The fast charging increases the risk of defect. Thus, thinner walls require materials that are high strength and more durable. To overcome plug housing challenges, molding thin ribs requires high flow and durable materials, and the final components must retain a balance between toughness and stiffness. High-strength weld lines are very durable. However, finding materials with the right balance between toughness and stiffness remain a challenge. There are safety concerns because the newer, thinner devices pose fire risks. Connectors with higher voltage rates and smaller pitch may experience electrical breakdown. Tracking resistance of material is key to reduce fire hazards. Insulating plastics may create these fire hazards. The buildup of dust, sweat, or moisture contamination can create a conductive track on the material, increasing the fire risk. You can see the significant burn marks and electrical breakdown in the diagram. This tracking resistance test shows material needs to have a high CTI to decrease safety risks. You can see in the diagram that after 60 droplets, only electrical corrosion appeared on the connector, with no structural damage. Charging electronics have been linked to device fires. Some fires may result in property damage or injury. If liable, manufacturers risk recalls, damage to their reputation, and legal action. With USB Type-C, the smaller pitch and increased power density may further increase the fire risk. Fires due to electrical failure primarily involve arcing, and arc faults are often caused by damaged connectors. Several considerations go into choosing the best material for the USB Type-C receptacle tongues and plug housings. By choosing a halogen-free polyamide, the risk of fire will be reduced. Stanol is a high-performance aliphatic polyamide that minimizes fire risks and increases product reliability. Its high CTI reduces the risk of tracking by 50%. It has excellent flow properties. It provides up to 50% more wear resistance compared to other high-temperature polyamides. It offers an unmatched reliability during use. For more information about Stanol, please contact your account manager or visit www.dsm.com/engineeringmaterials.